This screencast is on naming ions, and we are going to talk about how we name ions that are in the group A elements, the transition elements, as well as polyatomic ions. So the representative elements are those elements that are located in the S block and the P block of the periodic table. And as you can see in the diagram, okay, they have a positive charge if they're metals, and they have a negative charge if they're nonmetals. So every element in group 1A will have a charge of +1. Every element in group 2A will have a charge of +2. The elements in group 3A have a charge of +3. Typically in group 4A, there is no charge, and that's because they can either share electrons or gain electrons or lose electrons depending on what they are. So carbon typically doesn't have any charge. Silicon, germanium, they can kind of go either way. Lead and tin act like metals. They are metals. They act like metals, so they're going to end up with positive charges, but they act like the transition metals, and we'll get to that here in a minute. If we move over to column 5A, excuse me, that's where our nonmetals start, and these elements are going to have a -3 charge. And then moving over to column 6A, we have a -2 charge. Group 7A has a -1 charge. Group 8A are the noble gases. They have no charge. Recall that elements want to have a full valence shell, meaning they want to have 8 electrons in their outer energy level. Noble gases do that, so they don't tend to gain or lose electrons, which is why they have no charge at all. So what I'd like you to do is please take out your periodic table. You can use one that we've written on recently, maybe the one that you wrote 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A on when we were talking about valence electrons. And above these columns, I'd like you to pause the video and I'd like you to write the charge for the elements that are in these columns. So +1, +2, +3, 0, -3, -2, -1, and 0. When you're finished, resume the video. So when we're naming and writing symbols for the representative element ions, we need to remember that the metals form cations, which means they're going to have a positive charge. And the name of the ion is going to be the same as the name of the element. Okay, and the symbol of the ion is just the symbol of the element plus the charge. So for example, Cs+1 is called cesium ion. Ga+3 is called gallium ion. On the other hand, the nonmetals or the anions change their name. So when you take a nonmetal and you add electrons to make it an anion, the name is going to change. We change the ending of the name to end in IDE or IDE. The symbol of the ion, just like for the cations, is going to be the symbol of the element plus the charge of the ion. So selenium, when it gains 2 electrons, it will have a -2 charge. The symbol is Se-2, but it's called the selenide ion. Phosphorus, when it gains 3 electrons, has a symbol P-3, and it is called the phosphide ion. On a piece of paper, what I'd like you to do is write out these practice problems. Okay, so for potassium, bromide, aluminum, nitride, hydrogen, and chloride, I'd like you to look those elements up on the periodic table and write the symbol for the ion, remembering to write the charge. And then for the symbols that are given on the right side of your screen, I'd like you to write the symbol followed by the name of that particular ion. So pause the video at this time and write that on your piece of paper. And when you're finished writing that, please resume the video. So next are the transition elements. The transition elements are called the group B elements, and they're in the middle of the periodic table. They're the D block elements, and these elements can have more than one type of charge. And you can see here as an example, I have iron. Iron sometimes has a +2 charge and sometimes it has a +3 charge. And so when we're naming compounds, we want to make sure that people know, are we talking about the ion that has a +2 charge, or are we talking about the iron that has a +3 charge? So we have to make sure that there's something in the name that lets people know which charge we're talking about. So notice that the Roman numeral that we write is going to match the charge of the element. So iron that has a +2 charge is referred to as iron 2, and iron that has a +3 charge is referred to as iron 3. You can assume that all of the elements in the transition metals have more than one type of charge. The ones that do not are silver and cadmium and zinc. Silver always has a +1 charge. Cadmium and zinc both always have a +2 charge. And because these elements have only one charge, we do not write the Roman numerals. So again, in your notes, what I'd like you to do is write down Ag plus 1 is silver, Cd plus 2 is cadmium, and Zn plus 2 is zinc. And those are the names. Notice we don't have a Roman numeral after the name. We just give it the name of the element because there are no options here. These elements always have the charge that's indicated. There is no other charge that they can have. So once you've written these down, you can resume the video and move on. So we have some more practice problems here. Again, on your piece of paper, what I'd like you to do is write the symbol for the copper 1 ion, cadmium, gold 3, and nickel 2. And I'd also like you to write the names for the ions that are listed on the right side of your screen. So once again, pause your video, complete this assignment, and when you're done, you can resume the video. The last type of ion we're going to talk about is a polyatomic ion. If we break that word apart, we see the prefix poly, which means many, and atomic referring to atoms. So a polyatomic ion is an ion that's made up of many atoms. The definition is that it is a tightly bound group of atoms that act as a unit and carry a charge. Typically, when we look at the names of polyatomic ions, the names usually end in "ate" or "ite. And those endings, those suffixes have meaning. "Ate" means that it has one more oxygen atom, whereas "ite" means it has one less oxygen atom. So for example, SO4 with a -2 charge is called sulfate, whereas SO3 with a -2 charge is called sulfite. So you can see the difference in the number of oxygen atoms by looking at the formulas. What I need you to do now is to please pause your video and look up the polyatomic ion symbols for the following common polyatomic ions. We have acetate, chlorate, cyanide, hydroxide, nitrate, nitrite, carbonate, sulfate, sulfite, phosphate, and ammonium. These you are going to be responsible for memorizing. So pause the video so you can look at the list and look up the symbols for these polyatomic ions. You should add those onto your notes. Once you have finished all of these notes and practice problems, you may either turn in your handwritten copy to Mrs. Benke in class, or you may take a picture of your notes and upload it into Schoology.